right. Hello, everybody. Thank you. We're glad that you could join us today. We're very happy to have you here. So please take a moment to settle in, grab your coffee, and get comfortable. Whether you're tuning in from a plant floor or if you're somewhere or an office or somewhere in between, we're thrilled to have you with us. Today's conversation is about deploying efficient robotics, efficient robot automation for the shop floor, and more importantly, what it means for you and the work you're doing. Put this session together to give you something practical, real insight you can take back and put to use, not just talking point. Here's how we'll run today. We'll keep things focused and leave plenty of room for your questions. So please drop them into the QA box whenever they come to mind. No need to wait until the end. So make yourself at home. Jump in whenever you'd like, and let's get into it. Thank you again for being here. Today's webinar is presented by Strategic Value Plus Solutions and KDM Consortium. Strategic Value helps small and mid-sized U.S. manufacturers close the quality, delivery, and compliance gaps between them and OEM businesses through readiness assessment, qualification road mapping, and hands-on execution. V Plus moves companies from capable to OEM ready. Backed by the V Plus Edge platform and a nationwide network of vetted experts, the firm turns supplier qualification into one contract. KDM Consortium unites 5 strategic pillars: government contracting, manufacturing, critical minerals, opportunity zones, and access to capital into one coordinated engine for readiness, scale, and impact. Built on the belief that the biggest opportunities are never won in silos, KDM aligns public priorities with private execution, so partners move faster and win together. Anchored by a national hub zone digital ecosystem, the consortium turns opportunity into contracts, production, and investment. AI, digital twins, automation, and robotics are no longer a competitive advantage. They're becoming table stakes. But for most manufacturers, the gap between knowing they need to modernize and knowing how to do it without breaking what's already working is enormous. In this practical, no-fluff session, manufacturing executive and operations strategist Arthi Sairaman draws on 20 years plus experience deploying automation across 6 continents to give you a clear-eyed view of where robotics and smart manufacturers are headed and what it actually takes to lead that transformation on your shop floor, not in a PowerPoint, although we'll use that today. Who this is for is manufacturing owners and operators at engineered to order or complex multi-stage factories, facilities, plant managers, and operations leaders evaluating automation, private equity, and board members overseeing manufacturing portfolio companies, supply chain and digital transformation leaders navigating workforce and technology change. So what we see today are a grounded view of where AI, digital twins, automation, and robotics, and smart manufacturing are creating real return on investment and or the reality. You'll also receive a framework for assessing your facility's automation readiness based on manufacturing technology balance sheet used with manufacturers from Indiana to India. You'll receive practical guidance on aligning digital investment decisions with operational flexibility, workforce transitions, and enterprise value creation. Most of all, you'll receive straight talk from a luminary in this space. So it is with great pleasure I introduce you to Arthi Sairaman. We're really glad to have her here. She's a certified SIRI assessor, a fractional executive. She's delivered manufacturing programs across 6 continents, spanning robotics, CNC, industrial automation, and digital twins. And she's connected workforce platforms. Her work has produced up to 12% EBITDA improvements and 10% cost to serve reductions. She partners with manufacturers, boards, and private equity firms to build shop floor modernization strategies at work in the real world. Thank you very much, Arthi. It's a pleasure to have you here, and thank you for spending some time with us to clarify this space.
Thanks, Nell. That was quite an introduction, and I would say that a big shoes to fill now.
Oh, no, you're there. Thank you. We're very, very pleased and honored to have you here.
So
I'll let you take the floor.
Thank you so much. Well, first of all, are folks able to see the presentation I shared? Nell, can you confirm? Okay, let's see. I am assuming folks are able to see my screen. In case you're not, Nell, I would there we go. So with that, let me quickly go to this next slide. In my next slide, I want to share with you what my background is. Right? I identify myself as a manufacturer first, and over the last 15 plus years, I led advanced manufacturing and automation firm with a strong portfolio of about 120 products, which were included CNC, robots, AGVs, and modular automation systems that we could build together to put together factory automation, connect them digitally, and serve our customers with the right results. Now, one of the things that I learned as a manufacturer was to make sure our products were always modular, configurable, and expandable. The reason is that's what manufacturers are expecting as they are investing in these kind of capital equipment. Quite early in my work at this company, we started leveraging Industry 4.0 and smart manufacturing technologies, and we put them to use in our business as well as manufacturing processes and activities. That resulted us in standing up an Industry 4.0 vertical within our organization. And as we started doing that, we started thinking significantly on how this is going to be affecting the next generation workforce development. Right? Just as we were doing things, we were expecting the people that we were hiring, the people who were already working to learn new technologies, and resulted in us building a strong relationship with respect to smart manufacturing, smart factory with academia around the world. We built multiple centers of excellence. I want to say about 400 plus across the world. And these centers of excellence were built so that they could act as test beds for manufacturers themselves. Now, the next slide, I want to talk about the impact that we were able to create in that 15 years and continue to do so, right? As an organization, we're a small company, but had a global footprint. We went from about 6 countries to 30 countries across 6 continents. We took our portfolio of 100 to 120 products and put together more than 465,000 installations, which included hardware, digital assets, as well as learning assets that went into multiple organizations. But the thing that my team and I were always grateful and proud of was the impact we created with respect to the workforce. More than 100,000 trained users, and most importantly, 1 million plus students trained on our technology and went on to work in different industries. Still pleased to know that many of them come back to us and tell us what got them started in this manufacturing and automation career. So, next slide, please. Why this topic is important now, right? We have a resurgence of manufacturing here in the US, and we talk about labor constraints. But labor constraints is not something which is isolated just to the US. This is something even faced by countries where manufacturing is fairly well entrenched. The key reason is that manufacturing career and awareness is still very low, and people choose not to come into manufacturing career because they have some old-fashioned ideas about what this is. The second thing which is happening is that we have set high bar for quality, right? We are able to get good quality products from our manufacturers, and that means there's a lot of pressure to make sure that even when you're coming up with new products, whether it's automation or even simple gadgets that we use, expectation is very high. Now, this is putting a lot of pressure on our manufacturers to meet the demand, and they are thinking how to achieve that. People is one aspect of it, but they're also thinking about investments that they make in terms of automation, capital equipment, and how to do it efficiently so that there is return on investment. Because at the end of the day, anybody who is in business is there to make impact and also make money. So manufacturers cannot afford automation projects that are underwhelming for their organizations to not meet their business objective. Next slide, please. So what's the biggest issue that I have seen in terms of automation, right? When things do not work, the people who take the blame, one is, of course, the robot itself, the tool itself, and the other is the automation vendor not meeting their expectation. But that is robot is how it needs to be effectively used in the organization. This is also directly related to how the organization thinks about automation in itself. Next slide, please. So when we talk about automation projects struggling and failing, let's think about a few different points, right? When I go into a manufacturing organization, right? A lot of time, they already have a bar set in terms of what they want to deploy. And let me lead this with an example, a real example that I went through. A manufacturer, a machine shop, was facing a significant delay in orders, and the owner of the machine shop had a standard conversation with the supervisor, and the supervisor provided some data, which is reactive data collected from the shop floor, asking why their orders were so backlogged and delayed in terms of. The supervisor did have a good information, but it was reactive information. And he said that they were fully loaded on their machines. They were running 2 shifts, and they think that it is a capacity issue. Maybe we should consider adding new equipment or another shift in order to meet their backlog orders. Now, the customer came to us saying that, what can we do? Do we look at adding another machine into their line in order to meet the capacity issue? Our approach was a little different. We dug a little bit more and I said, okay, do you know what is the actual utilization on your machine? And while you go ahead and collect the information and what you need in order to raise money or get the investment you need to put in a new machine, let's go ahead and measure what's happening on the lines, the machines themselves. And we found that the machines were running at less than 50% utilization. So with that data, they were able to take certain decisions, which was just about process improvement and get another 20 to 30% of their capacity, right? So I want to tee up with that example. So with respect to automation, right? When manufacturers, when operators come to us and ask for automation solutions, one of the things that we look at is, are they willing to make certain changes to their layouts to accommodate the automation? Because sometimes automation is more effective when there is a layout change as well. This is an important point. The second is that many manufacturers, they look at automation and they look at it as a sized and locally optimized solution. So which means that manufacturers today, if they are bringing in IT later into the conversation, it is a surprise, and you can definitely avoid that by doing the planning earlier. And last but not the least, we talk about workforce, we talk about training for the automation skill set in the workforce, but what we don't realize is that when we introduce any tool, be it physical or digital, it is changing the job profile, the skill set, and the competency, which means that we need to update our job description as well. So these multiple small things which could go slightly wrong in different manner, but they add up, resulting in potential delays, unhappiness, and failures in terms of why automation. And I have seen situations where even in large enterprises, I've seen robots and AGVs sit as massive in paperweights in their shop floor. And remember, the shop floor, every square foot is usable and value added. Next slide, please. So how do we look at this value chain, right? The framework that I like to use from an executive perspective to discuss whether to go for automation and how to discuss that automation project starts with the business objective. Give you an example of that capital expense where capacity was lost on the machine and how that could be grabbed by making simple process changes, right? So the business objective really helps us understand whether this is something which needs to be addressed from a process perspective. So you understand your process, the value of digital tools and how they can be used in multiple ways in order to understand what is the scenario that you're looking to solve for and what's the best way to solve for it. Then, of course, comes the physical deployment, the workforce adoption, the training, as well as giving them a strong understanding of how this is actually going to take them forward in their manufacturing career. Now, most manufacturers are well aware that they have a lot of data, and there is a tremendous amount of data that is actually lying dormant on our machines. But today, we continue to take that data only from a reactive perspective, and there are ways in which we can actually use this proactively to drive decisions up and down the value chain, as well as the stakeholders who are in the manufacturing ecosystem. Of course, with any automation or any investment, what we are looking at is how do we connect the financial outcomes to the original business objective and how it gets broken down into the respective KPI across the entire ecosystem. Next slide, please. So we will start with 2 case studies. And this is what I had in mind when I was preparing for this talk, this webinar. One is from the perspective of a traditional manufacturer and traditional automation supplier. And that would be someone like myself who have done this kind of work for several years. And another one from the perspective of a manufacturing startup and how they are leveraging technology to give manufacturers modernization as well as increased capability. So in the first example, we have a mid-sized CNC high volume manufacturer automotive components. And to protect the privacy of our customer, these images are generated, but fairly true to what we are talking about. The automotive component that they are looking to manufacture typically has 2 operations. The first operation is on a CNC mill with about 15-second cycle time. And the second one is on the lathe with about 10 to 12-second cycle time. Right? The way they have laid out the floor, we're talking about these long assembly floors, machine after machine after machine, and dedicated operators who are loading and unloading the machine. Now, with operations that are only few seconds, you can imagine how quickly they are doing this activity of loading the workpiece, doing the operation, removing it, doing the next one, transferring it to the next station, etc. This can get pretty boring, and it's also high fatigue because of the repetitive operations. And this particular unit was running it for 2 shifts. So they were seeing high variability in productivity. And more importantly, on the people side of things, what they were seeing was they were seeing high absenteeism as well as turnovers. This is the turnover of employee, right? When we talk to the supervisors, and this is where the what else question happens. The plant manager, the head of the manufacturing, came to us saying that, hey, we're having this problem where we're seeing high variability in our production. Can you help us solve this with automation? So, absolutely interesting project. We are CNC machine tool builders as well as robot builders, so why not? Let's look at it. Next slide, please. So, the project is pretty simple, right? They're saying that we want to automate. We want you to think about how do you automate. If you go into an organization like this, right? They already have multiple questions swirling within the organization. There are the manufacturing, the plant engineers who are thinking about, oh, what kind of robot should we buy? What should be the payload, the reach that we need for this robot? Should be they're thinking about collaborative robots as well. Then comes saying that, okay, we need to have this flexibility to change the setup because we might want to change parts that we want to run through the machine. So how do we go about? So there's these technical questions which are happening. And then we have the maintenance and the repair team, the engineering team, which is managing the machines, which is saying that, oh, we're going to get some new equipment. How do I think about maintaining the equipment? Do I need new skill sets? What are my requirements? Oh, I hear about this remote management of these machines. Should we think about getting that? Will that help us give better uptime to our customers, to our customers, being internal customers, the plant operators and the shop floor folks? Then they are talking about why we are doing this. How do we stabilize the productivity and increase the throughput that we have within the organization? There are questions around what kind of material buffers do we need? Can my quality inspection keep up with it? Then we have the HR team, which is saying that we're introducing something new. Do we have some safety requirements that we need to meet? OSHA reporting requirements. Or we have operators. How do we think about training the operators? Are we going to now have more operators? How do we deploy them, right? If you're able to free up time, how do you deploy these people? And then, of course, as your CXO office is thinking, are we ready for this? Change management, layout, etc. So these are all considerations in there. If you look at most organizations, these questions are swirling in pockets. Each one of them is talking about it. And typically, when we are sitting across the table for automation discussion, not all stakeholders are at the table. This is where we find, and we always found, that a conversation with multiple stakeholders, understanding what their requirements are, is superbly important for making sure that automation is successful and is adopted by all the people who are in that organization. I tell you that there are many times we have had issues when we have not had, say, the maintenance team in the conversation, and they come back and they poke at the solution that you've delivered in so many different ways that it turns out to be extremely tedious for the automation vendor as well as for the champions of these kind of projects. Next slide, please. So in this slide, what I wanted to show you here was that with this customer, the CNC machine shop, we started doing iterations, right? Digital iterations. I mentioned to you early on that we started adopting a lot of digital tools early on to make it helpful for us to deploy products at our customers. The digital iteration allowed us to show them what are the different ways in which they could actually position their machines so that they can take advantage of higher productivity coming through. So a few different iterations. The last one is a video, but I'm not sure if you're going to be able to play it or not. But the one on the image, the larger image on the right, is actually a video clip which shows how this particular cell was finally designed and accepted. So it is behind safety fences. We are using a high-speed industrial robot. And as we did the exercise of understanding how the machine layout changes and how to meet the productivity requirement, we learned that we would need about 2 lathes to process the 1 milling, again, for 1 milling machine which is out there. So this particular layout helped the different stakeholders, whether it's on the shop floor, whether it is management, to understand what their system would look like and whether it meets their standard operating procedure requirements with respect to operations, safety, maintenance, etc. When the video plays, you can actually see this person walk into the cell and interact with the machines, know how to go about the cell in order to do any maintenance requirements, etc. So let me just pick from an operator perspective. The role which has changed here is that the machine is going to be pretty much running everything automated. The operator's role now changes of how to make sure safely enter the cell and ensure that material is available for that robot to continue to load, unload the machines and operate, and then remove the finished goods and take it into the quality system. The operator needs to be trained on how to safely enter, how to restart the robot once the pallet is exchanged, and in situations, maybe go in there and change out the tools because tools wear out and they would need to do that as well. From the maintenance team perspective, they all know how to maintain the CNC machines, but now they need to understand how to maintain a robot as well as calibrate the robot. One of the frequent wear out parts that you would see in these kind of high volume operations is that the grippers tend to wear out. And they would need to know how to switch out the grippers, do the recalibration so that this cell functions correctly. Next slide, please. Now, why this was a digital twin? It was an offline digital twin, right? So we had several assets. We were able to bring them modularly together to showcase what that would look like. In this particular exercise, we also learned that today's process looked at material was, crossing paths, and that creates safety issues as well. Oh, sorry, just a second. Apologies. So what we also learned was that material was basically crossing paths, which can also result in safety concerns as well as potential material damage as well. So we were also able to look at what should be the flow of material across the cell, across the shop floor, and these gave opportunities to our manufacturer to make improvements in the process. Next slide, please. So the doing this simulation exercise, and there are several tools which are available to do this kind of simulation, and some of them may actually be available within your existing engineering portfolio of software as well. What we were observed was that there were changes that needed to be done in the entire process as well, and these are simple changes, right? In the upstream processes, because of the higher productivity that we were delivering this cell, we needed to make sure that material was available sufficiently in the stores and was able to be delivered to the robot cell on time. So what was to be maintained in the shop floor. Then from a downstream perspective, once the finished product comes out of the cell, how is the quality team prepared to take in that higher throughput? Do they now need to reduce to sampling exercise or adopt a few different techniques in order to make sure that if they are critical components, they have the necessary specs captured before they are going into the customer flow. This also changes the procurement because now you have 30% more throughput. So you need to make sure that you are able to talk to your suppliers on how material delivery gets scheduled as well. Now, typically, when we do this kind of digital twin or simulation exercise, about 80 to 90% of what we need to capture from the automation perspective, we are able to do that in a digital manner. But about 10 to 20% still ends up things which we discover while we are building the automation solution, while we are deploying it at the customer site as well. Next slide, please. So I want to now take this from the perspective of what we did for that consultative automation deployment exercise and the data that we got, which started driving better decisions across the shop floor, right? From an operator perspective, as operator and supervisor, they definitely look at, is this safe for the operator to work with? And what are the skill sets that we need this operator now working with the robot to be fully trained on? When we have operator capacity freed up, how do we think about redeploying them across the shop floor? So these are conversations that they were able to prepare for during this planning exercise instead of trying to address it post-deployment. From the maintenance perspective, right? And I mentioned earlier that sometimes it is the maintenance which could potentially cause an automation project to fail because they have not been consulted or trained on how exactly this system is going to be maintained. They understand what are the spares they need to carry and what their expectations or the expectation of them is going to be for ensuring there is high uptime on these robotic cells. This is absolutely needed in order for automation to be successful. Quality team with higher throughput, they need to reconfigure their process to be able to take in and ensure that you're looking at the throughput from the start to getting it in the customer hands. And the plant manager and executives also start having higher visibility into what is happening on the shop floor, how they can redeploy, how they could potentially, a rush order for a similar type of component. Now, this particular implementation, there was a lot of data which was available, and I'll be honest that not all of the data which was available was being used, but there is potential for them to be able to do so in the future. Next slide, please. So, what was the outcome of this particular deployment? Right, where we were seeing, there were about four operators that were working across two shifts over there. 1.5 operators per shift were freed up so that they could do something else, something of more value within the throughput, the variability that we're seeing that stabilized, and we also started seeing increased gain through the entire value chain because we were using a continuous tending which was not experiencing fatigue. We also saw that the overall equipment efficiency, the spindle runtime, and overall utilization and first pass yield increased from that setup. Safety, this is important as well. We were having fatigue, absenteeism, and I'm going to connect the safety and the people ROI together. We started seeing lower amounts of those with the robot automation. What changed, especially on the people ROI front, was that you started seeing a decrease in the folks who are or people leaving the organization in the cell that was deployed. This was because these operators were learning something new. They could see a more interesting career path. They could see a path which was towards programming the robots, managing changeover setups, going and working in the maintenance, picking up skills in terms of quality because the additional time they were also trained on the quality side of things. So this was the outcome from one of the case studies. Moving to the next one. Next slide, please. This is a case study which I wanted to talk from a new age manufacturing startup perspective. Right? There are a ton of companies, several companies who are actually using some good use cases and experiences that they have had with manufacturing to come up with solutions to solve for legacy manufacturing and modernizing them. And one such company that I had the pleasure of working with is R2 Labs. They are based out of Atlanta, and they are a phenomenal team which has manufacturing experience and has understood how to use the concept of artificial intelligence, machine learning, computer vision, controls, and make it a solution that can fit into legacy manufacturing. They have a principle that they work with, which is no rip and replace, meaning that work with what the manufacturer has and make them better by augmenting their technology, their solution with R2 Labs products. Next slide, please. So in this case study, we're talking about a fabricator who makes sheet metal parts, and they have multiple product lines. And the issue that they're doing manual inspection of their sheet metal parts. Again, if you are watching these parts for paint defects or sheet metal defects, you find that after the first hour, it starts becoming extremely tiresome and errors happen, right? And when errors happen, that means that either you are rejecting too many parts or a bad quality part slips into the customer, and then you have this whole thing that you have to deal with the customer returns and increased scrutiny to make sure this doesn't happen, and it keeps adding up in terms of your workload as well as the cost to the company. So this fabricator was looking at two options. One was go to a traditional automation vendor and come up with a solution that required significant line changes and also capital expenses, heavy capital expenses. And some of the folks who are here wanted to actually take a more innovative approach. And the novel approach that they decided was taking into consideration what R2 Labs builds and slipstreaming it into existing line, giving the operators and business supervisors visibility into these quality issues. So this is where R2 Labs comes in, and I definitely will make sure that we'll talk about the product that they have put in over there. Their solution was simple: minimum interruption to the product line. A lot of stuff was done ahead of time in terms of in the simulators to be able to result in the solution itself. Next slide, please. So what R2 Lab has is something called RAC, R2 Autonomy Control. And this is a control tower that is capable of connecting with any type of equipment, age no bar, brand no bar. It could be any control system, a CNC control, PLC, PID, microcontroller, whatever it is. Be able to talk to these different kinds of systems, unify them, gather information, and use that information to give visibility to the people who need it, right? So, which means that from an integration perspective, their solution allows you to quickly integrate multiple types of assets which are available on your shop floor and make use of the new technologies that are available to them. In their case, what they deployed was a computer vision system for the quality inspection in as short a time frame as possible. Now, their system actually allowed you to do certain things instead of sequentially. So they were able to gather the data images of what a quality defect would look like, be able to train their system algorithms using artificial intelligence and machine learning to build algorithmically how to spot what defects are, run it through a simulator, train it sufficiently, bring it and deploy it at the shop floor. And as I mentioned, right, you can train 80% of it is done away from the shop floor. But then balance 20%, the little bit of fine tuning, which always happens in automation, was done on the shop floor and got deployed. What they got out of it was that they were able to deliver, and this project is still ongoing, is that 25 to 30% more throughput for the customer, 20% reduction in idle time, and more than 19% reduction in reject rate. Imagine rejecting good parts. And the cost of rejection is never the part itself, right? If you look at the fully loaded cost of a factory for a rejected part, it is significant. And that's a lot of saving when you're able to reduce rejection by more than 20%, right? Next slide, please. So as we come towards the wrapping up, summarizing, from a framework or playbook perspective, when you're as a manufacturer, when you're considering automation, I would like you to think about it in different phases. And the first phase is all about you learning about your organization. And this being a consultative exercise actually benefits manufacturers significantly. Even if you're a small manufacturer, this has huge benefits because you learn a lot about your organization and what you need to make sure is in place for the automation that you're deploying. And this can be physical or digital automation that is going to be successful for you. That means knowing what are your business outcomes, understanding and mapping your process fully, and then knowing who are the different stakeholders, including the shop floor, IT, workforce, and what is needed by them in order to deploy automation. So this is first part of it. The second part of it is that I want to take you to this how we learn, right? Think about how you learn, how your kids learn. And you find that we learn by watching things as well, right? That simulation, that digital simulation that we are talking about is very valuable because it allows you to take what would traditionally be maybe a 30 or 40 page document statement of work and allows you to visualize how that needs to be done, right? The digital twin I mentioned earlier becomes an asset. It definitely is an asset for us as a manufacturer and automation deployer because it allows us to quickly look at what my bills of material are and cost it correctly. The second thing is that it becomes an incredible sales tool for us because we are able to show to the customer what their automation would look like. The third thing, right? We're talking about what are the ways in which you can actually prepare before go live. And going back to the offline simulators, the digital twins, we use it extensively to test out our programs, our interfacing in the digital environment before we actually put it in the physical. So we're able to catch a lot of issues there before we transfer the programs into the overall control system. And as I mentioned, training the workforce. You understand what skills are needed. You understand what training is needed, how many people are going to need to be trained, etc. And lastly, right, the digital asset that you receive from your automation provider or anything that you have built in-house, keep feeding it, keep making it better, and keep using it for your scenario planning, for your what-if analysis, for any changes that you want to run through your production system. Absolutely use it for that. Now, this is all when you know that you definitely need automation. And then I have another set of customers who don't know where to start. Next slide, please. So when you have a situation where from a modernization perspective, you're a manufacturer who doesn't have yet what are the top initiatives to invest in, I highly encourage you to look at the Smart Industry Readiness Index. This is an evaluation which is actually a global evaluation standard for manufacturers. And the way this is done is that it allows you to understand the maturity of your organization from multiple perspectives, not only digital perspective, but also your process interconnectivity, the technology which is deployed on your shop floor business, etc., and your organization's understanding and readiness of what modern manufacturing looks like. This exercise can be done as a tactical one, which is a 6 to 9 month, and tells you what are the top 3 initiatives that you need to look at in the 6 to 9 month period. And those are typically, big pain points that need to be addressed immediately. Or you can look at it operationally between 12 to 18 months on what you should be investing on to build capability, capacity, and the flexibility to respond to opportunities that are coming your way as well. Most importantly, it allows you to see how you stand in your maturity against the best in class in that particular industry. And this industry, we're looking at it from a global perspective. So you are looking at companies, hundreds of companies across different parts of the country and the world, and you see how you position against them. And if you're at the leading edge, great, you stay in that track. And if you're lagging, then there are opportunities to quickly pull yourself to the broad middle and then work towards what best in class looks like. Next slide, please. So as we wrap up, I wanted to say that when you're looking at automation, take the time to understand your process well. Definitely lean on digital validation. Ask your automation vendors about the digital validation capabilities that they have. And then data, right? At the end of the day, the reason you're doing this is to improve some outcome within that business organization, all the way from the shop floor to the C suite. So, understanding how that data is going to help you is going to be tremendously useful. And when you know these points, deploy confidently. You need to move forward. One step forward is better than just standing still and trying to figure out, saying that, hey, I need to know what has been proven out 100% before I will take the first step. Probably not the right way to look at it from manufacturing. Think about this as a test bed that you will constantly evolve to make your organization better, your functions better, and your people better. So with that, I am open for questions.
All right. Thank you so much, Arthi. That was amazing. So much to think about. So we have a couple of questions, and one of them is, so robotics has been consistently been an investment that manufacturers are looking at very seriously. Can you give us an idea of what return on investment time frame they might be looking at? I know it depends on what kind of robotic they plan to adopt, so there's a range. But ultimately, would they expect a return on investment like
Yep.
in about 3 to 5 years, or is it like a 10 to 15 year time frame?
No, so it also, the level of automation that you're looking at also matters, right? So that's why this understanding the level of automation and how integrated that needs to be within an organization is super important. But typically, if you are doing, more of a cell-based automation, you're looking at about 18 to 24 months to get your full ROI. And the more thoughtful you are in that process and how that automation and the information and data that you actually pull from that feeds into your organization, that time frame starts coming down even further. So being thoughtful, taking that time for planning, super important. Nell, you're on mute.
So sorry. Thank you. I'm talking away. That is a shorter time frame than I would have expected, meaning that there's a lot of improvements all across the board that can be added into the return of investment. So, but before they get started, then, do they need to get pretty well grounded in their standard operating procedures so that the programming of the robot can be done more efficiently? What do they need to do to prepare?
So as I said, right, most manufacturers, they jump in and they decide that this automation or a robot is the solution, is the way to go for their issue. And I find that when we're looking at automation, you basically you latch onto a problem statement and you stay with that. And it may not be a situation where that is truly the problem. It might be other things which are actually causing the problem, and automating what you're trying to automate may just highlight that problem in a much more glaring way than you expected. And then what happens is that the blame goes around. It's a robot, it's the automation vendor, it's a champion of the project. So, in my opinion, is that when you are looking to automate, being grounded on what your process is super important. So you understand that upstream and downstream what's happening, and is there opportunity for you to solve the problem that you're looking at in one of those places before you look at automation? And if automation is absolutely the best way to go forward, then still making sure that you are not ending up creating bottlenecks or missed opportunities by implementing it. So that first step that I talked about, phase 1 and phase 2, do it. And many enterprises are actually investing in these kind of digital simulations to understand what their factories look like for that very reason, because they want to know, if I make a change, if I try to bring something else new, is it going to run efficiently? Am I going to run into bottlenecks? The one partner that I met at Strategic Value Plus, I think the Goldratt Institute and their theory of constraint, I think it's a fantastic way to think about what would your supply chain look like, right? And that is a type of digital simulation. I would actually do something like that.
Excellent. So one of the big worries on the shop floor inside manufacturing companies is that people will lose their jobs. So to robotics. And could you give us a response to some issues that adoption might entertain for a company?
I would say that it's my opinion, but I think that people are now more worried about AI than I would say about robots. People do recognize, right? Especially operators within factories, they realize that robots can be helpful, and especially give them a safer and more interesting work environment, improve their skill sets. So I see it change, especially with the next generation of students wanting to come into to robot. They want to solve interesting problems. They just don't want to do loading, unloading. They want to think about maintenance. They want to have more systems based thinking, right? So I think that with the legacy manufacturing, with the challenges that they are facing, and with them wanting to attract talent into their organization, robotics manufacturing technology which actually uses AI is actually going to be more attractive for them to get talent inside and create a career path which goes beyond just the shop floor, keeps them making a better value chain. And I see that there is a cross pollination which gets created across the industries because of that, right? If you have a strong understanding of robotics, you don't need to work only in the machine shop, end up working in, I don't know, somewhere else in the logistics and distribution, or in, let's say, city planning to figure out how for traffic control.
Excellent. So are there any final words that you'd like to share with us as we draw to a close?
So for the folks who are here, my contact information is there in the slide deck. If you want to set up a 45-minute conversation on how you need, if you are considering automation, you want to an insight into how to think about it, or you want to undergo a smart industry readiness index and where do you want to start with it, please feel free to reach out to me. Happy to have that 40 to 1 hour conversation and set you on a path that would hopefully get you 2 or 3 steps ahead.
Excellent. So I have Arthi's email in the banner, just ticketing across the bottom of the screen here. So reach out to Arthi at mtabusa.com and let her know that you found out about her through this webcast. And Arthi, excellent presentation. Really learned a lot. You took a lot of time to think through the case studies that you shared with us today. Thank you for sharing your slide deck with us. Anybody who would like to have a copy of the slide deck, reach out to me at info@strategicvalueplus.com and we'll get the copy of the slide deck to you. Okay. Thank you so much, everyone, for joining us today, and have a very nice rest of the week.
Thank you.
Take good care. Thank
Bye-bye.
you, everyone.